Hello, this is FlippedHarber for Physics, and in this video we'll go over the practice problems on page 135, numbers 38 through 41. In number 38, consider the crate on the incline in example problem 5. Calculate the magnitude of the acceleration. After 4 seconds, how fast will the crate be moving? Now here we see our crate from example problem 5. And from the example problem, we know that the sum of forces in the x direction equals negative 281 newtons. We don't need to do the work to find that. That's already in the example problem. So we're just going to use that number. We also know that the crate weighs 562 newtons. So that means that its mass is 57.35 kilograms. All I did was divide by 9.80. Now we're going to use our sum of forces and our mass in order to find the acceleration. All we need to do is divide to find the acceleration of the crate. We find out that the acceleration is 4.90 meters per second squared. Now in order to get the speed after 4 seconds, all we need to do is multiply by the time to get this speed. So we find out that the crate will be going 19.6 meters per second. Alright, number 39. If the skier in example problem 6 were on a 31-degree downhill slope, what would be the magnitude of the acceleration? So here we see our skier from example problem 6. And again, we don't need to do the work to develop what they've already got. They tell us that the acceleration in the x direction, that is the acceleration down the hill, is equal to g times the difference sine theta minus mu cosine theta. We're just going to plug in. We know what g is, and they're telling us that we're going to use 31 degrees as the angle. So plug in 9.80, and again plug in what they give us in the example problem for mu. We find out that the acceleration is 3.8 meters per second squared. Alright, in number 40, Stacie, who has a mass of 45 kilograms, starts down a slide that is inclined at an angle of 45 degrees with the horizontal. If the coefficient of kinetic friction between Stacie's shorts and the slide is 0.25, what is her acceleration? So here we see a picture of Stacie, and I've drawn in all the major forces, her weight, the normal force from the slide, friction, and I've gone ahead and split up the weight into its perpendicular component and its parallel component. Doing a sum of forces in the y direction that is perpendicular to the slide shows that the normal force is equal to the perpendicular component of her weight. Not a big surprise there, but it's always nice to verify what the normal force is. Doing a sum of forces in the x direction, that is down the slide is positive x, up the slide is negative x, we have mg parallel minus friction. Now this sum of forces, like all sum of forces, is equal to ma. It's not equal to 0. She is accelerating, or at least I think she's accelerating, so I'm going to set it equal to ma, not equal to 0, like we did with the previous sum of forces. So her acceleration can be solved by dividing the mass over. Now I can't cancel the m's as you see them here on the screen. mg parallel is not m times g. It's that m is involved in something. Now we will be able to cancel it in a minute, but please wait until you do that. mg parallel and mg perpendicular doesn't mean m times something. Go ahead and make the substitution what mg parallel is, what mg perpendicular is, then get rid of the masses, and we can plug everything in. We know g, because it's a pretty safe assumption, she's sliding on the earth, and we can plug in mu because they tell us it's 0.25. We find out that her acceleration down the slide is 5.2 meters per second squared. Alright, number 41, it says after the skier on the 37-degree hill in example problem 6 has been moving for 5 seconds, the friction of the snow suddenly increases. So the net force on the skier becomes 0. What is this new coefficient of friction? Well, again, here's our picture from the problem, and from the practice problem we know that the acceleration is equal to g sine theta minus mu g cosine theta. Well, we're just going to shuffle things around and solve for mu. But we first need to realize if the net force on the skier is 0, that means that his or her acceleration is also 0. So I'm going to set this expression equal to 0 because the net force is 0. And I'll start moving things around in order to solve for the mu. So notice that the two g's will cancel, and mu is just equal to the sine of theta divided by the cosine of theta. Now the problem says after the skier on the 37-degree hill, so that's what I'm going to plug in for theta is 37 degrees, and we find out that the mu is 0.75. So the friction went up because of an increase in the mu. Alright, so we're all done with this. It's time for you to try some problems on your own. I'll see you in class, and I'll see you online.